So we have another problem here, in which what we want to do is we want to answer this. It says the tide in a coastal city peaks every 11.6 hours. The tide ranges from 3.9 meters to 3.3 meters. Determine the height of the tide at 6.2 hours. So the end result is we're to determine how high the tide is when 6.2 hours has elapsed. The way we're going to have to solve this, though, is we're going to go back from scratch and look at how to graph this and come up with a correct model. Now, in the wording up here, we're talking about tides. And in class, we've talked about tides before. Tides are always cyclical, and anything that's cyclical can be defined by a sine or a cosine function. All right? So, let's do the graph first. So, if I just basically do an x and a y here, a horizontal and a vertical axis, just simply by looking at that, it says determine the height of the tide at 6.2 hours. So what I want to determine, what I want to find is always on my y-axis. So I'm going to determine the height, all right, and the height is in meters, at 6.2 hours, so my horizontal or my x-axis is time in hours. Okay? Now, if I look up here, I know a couple things. I know that the tide peaks every 11.6 hours. So we can logically assume that we want to begin our graph at 0 hours and end our graph at 11.6 hours. We also know that the tide has a peak of 3.9 meters and it has a trough or a low point at 3.3 meters. So just with a quick sketch, I know that at time 0, because it says that there it peaks every 11.6 hours. So at the beginning, at 0, I'm at a peak of 3.9 meters. And again, at 11.6 hours, I'm at a peak. Now it's got to have a bottom out point, and the bottom out point for these functions is always halfway through. So, actually I'll pull my calculator up. If I were to try to clear this, well, it won't. Good. Let's clear everything. If I clear this, right, I just want to do 11.6 divided by 2. Okay, we could have done this on our own. That's at 5.8 right there. So I know then at 5.8, I'm at a low point right here. And again, since this is cyclical, since it goes through cycles, we can figure out that we should have a wave that looks like that. It's going to keep going on and on and on forever, but this is the only thing we're interested in right there. So now what we want to do to determine the height, to be able to predict the height, we need to have an equation in which we can plug in 6.2 for x and or for t and come up with an h. So we need to begin to construct the equation. So here's our choices. Since we're talking about trigonometry, we have this choice. Y is equal to a times the sine of bx minus c plus d. Or we have y is equal to a times the cosine of bx minus c plus d. Now the big question is, which one do we want to use? Because we have a choice. We can use sine or we can use cosine. And the choice is going to be dependent on whether we want to use a c as 0 or whether we want to use it as something else. Now keep in mind, this is a trig function. It's a wave. There is a median line. We'll do it black here. There is a median line that always cuts the graph in half horizontally. So C is always the distance along the median line. Now what I mean is this. All sine functions, without any horizontal shift, intersect the median line at the origin, or at the y-axis. All cosines always start as maximums or minimums. So if we want to use sine, the one in red, our c has to be this distance right here. We have to figure that distance out. Is it doable? Sure, it's doable. It's not impossible to do that. But we would have to call that c. However, cosines always start at a maximum or a minimum. In this case, we're starting at a maximum, so our C would be the distance right here, which is 0. There is no distance, there is no shift. So just because of that fact alone, we are better off using the cosine equation as our model here. Again, we could have used sine, but we would have had to figure out that horizontal shift, and it's doable, but we want to avoid that if we can. So this is why we're going to choose cosine instead of sine. This is why we use cosine instead of sine. Okay, so now we've chosen cosine. So all we got to do is figure out A, B, C, and D. Not a big problem. Our A, remember, the A is the distance from the median line to the top and the median line to the bottom. A is always found by taking the highest y minus the lowest y and divide that by 2. If you do the math, you should get 0.3. So we know A is 0.3. The distance from the median line to the top is 0.3. The distance from the median line to the bottom is 0.3. Okay, I like to get D next. D represents the vertical shift upward, and what D really is it's a midpoint between the top and the top y and the low y. That's what it is. It's a midpoint, and if you remember your midpoint formula is one of the y's plus the other y divided by 2, and that should give you 3.6. Again, do the math in your calculator if you need to. So we know if we just start right here, we have y is equal to A 0.3 times the cosine. I'm going to leave the bx minus c part alone right here, plus d, which is 3.6. Now the next thing we want to find is b. And from our work, I'm going to do this over to the side right here, then I'm going to erase it. Here's what we know from graphing. We know 2 pi over b was the period. So from an algebra perspective, b is 2 pi over the period. So we know over here, I'll go back here in blue, b then is 2 pi over the period, and our period is 11.6. And we can leave it as 11.6, 2 pi over 11.6, or go to the calculator and do 2 pi divided by 11.6. That's 0.542 rounded. I'm going to use the decimal here. Okay? So we have 0.542, and I'm going to use t instead of x because I'm going to be consistent with my x-axis number. And then the only other thing is c. Well, we chose cosine because that means there is no horizontal shift, so c is technically 0. So if we want to rewrite this in its more basic form, it's 0.3 times the cosine of 0.542t. Put that in parentheses just to differentiate it, plus 3.6. That is our model there. 0.3 times the cosine of 0.542t plus 3.6. So we have our model. Now the question is have we then answered the problem? And the problem says to find the height when the tide is 6.2. So we want to know when t is 6.2, then the height is what? That looks like a 2, but it's meant to be a question mark. All right, and so what I'm going to do is I'm going to put this in the calculator. You can do it any way you want to. I'm going to go to y equals, and I am going to clear that one out, and I'm going to go ahead and clear the plot out too, only because I don't want it to muddy the water. Okay? So I'm going to type in my function in y1, so I have 0.3 times the cosine of 0.542t, I have to make that an x, plus 3.6. And when we're doing all these, we need to always be in radian mode. That will solve a lot of problems I'm not saying it won't necessarily be right in degree mode, but it's best to keep it in radian mode. I'm just looking to make sure I typed it in correctly. 0.3 cosine of 0.542 x plus 3.6. So what I want to know is when my height, or when my time is 6.2, what's my height? 3.31, we'll call it 3.31. So the height is 3.31 feet, or feet, tide range, meters, sorry. 3.31 meters, and that should make sense because at 5.8 hours, it's 3.3 exactly. So at 6 is just a little farther to the right. So at 6 hours, the tide should be going back up, and that's just a little higher than 3.3. So in a nutshell, the way we want to look at this is we want to sketch the graph like we just did there in green to get a good basic idea, and then we're going to choose either sine or cosine, and we want to do it in terms of, do we want to include a shift, a horizontal shift or not? Since this one starts as a maximum, cosine is the optimal equation rather than sine. And so then we just find A and B and D, and C is going to be 0 because we chose cosine to not have a shift, and then the rest is pretty much all algebraic. We found our function at the bottom of the screen there, and then we want to know when t is 6.2 hours, what is h? Plug in 6.2 for the t there, work it through, and you get an h of 3.31. All right, so I hope you found this helpful.